All right, we're going to talk about DSCP, and I'm on page 106. I'm at the top of 106 for the differentiated services field. And we'll talk about the old, and we're not going to talk too much about the old TOS fields, but we used to have 3 bits of precedence and then 4 bits of TOS type of service. And they changed it with differentiated services. It's not really terribly important, but now we get 6 bits of DSCP, and then 1 that tells it whether we can actually use congestion notification, and then whether or not we're having congestion. So this actually helps. It sets a priority for potentially, usually these are all zeros, but potentially sets the priority for whatever the packet is, and then tells the device whether there's currently congestion, whether it should act on that. All right, so the table, yes, no, okay. This is the table that is on page 106, and I want to explain a little bit because it is total gobbledygook, and the book tries to explain it, but I think they do a terrible job. So first of all, there is a class 1, a class 2, a class 3, a class 4, and this expedited forwarding. So this is a high priority. It's usually voice, and it'll be pushed through regardless. Then there is, and I don't like the way this table is laid out, but it is a low drop precedence, which means it probably will not be dropped. Then there's medium drop, which could be dropped. And then there's high drop precedence, which says, yeah, go ahead and drop it. So high drop will go first. It'll be the first casualty, and then medium drop will go, and then low drop, which I don't think it makes any sense. I thought to me, it should be inverted, but oh well. Usually you will only see traffic, and in the video we saw only had low drop precedence. So it only uses the classes. It doesn't use the precedence in there. And I think that's pretty typical. So how do we justify these DSCP 10 versus AF 11 versus this bit value here? So what we're going to do is we're going to actually do this DSCP 10. How can I do this? Can I do this on both on screen? I think, I can. Hang on. Oh, I can do them both on screen at the same time. Oh, hang on. Okay, that's better. I had turned the camera off, and it caches the last thing it saw. So that was RAID calculations from server class. Not that that was terribly important, but okay, let me zoom in here. So we were doing DSCP 10 or AF 11. So this is binary, and if I went back to the DSCP field, there's actually 6 bits. So we have 6 bits here: 2, 4, 6. All right. So, and this is really weird. The class can be 1 to 4. So these would actually be 1, 2, 4, 8. All right. So for us, the class is whoops, I did that wrong. Sorry. 1, 2, 4. It's only 3 bits. Sorry. 1, 2, and 4. And then the precedence is 1, 2, or 3. So that's only 2 bits. So this is precedence, and this is class, obviously. I have class. And then this, for some reason, we just ignore that last bit. I'm not exactly sure why, but that's how it works. So but if we're going to do DSP 10, so we're going to do 10, well, 10 is 8 and 2 with everything else filled with zeros. So its class is a 1, and its priority is a 1 here. And that's how we get AF11. AF11. Okay. Then if we go, let's pick something weird like DSP 38. All right. Whoops. DSP. There we go. Let's do DSP 38. So this would be the DSCP. DSCP is 38. So that would be 32 plus 6. Whoop, there we go. 32 plus 6. So this would be 1, 2, 4. So that would be class 4. And it would be precedence 3. All right. So that would be 4 AF 4 3. So it's just whatever's in this first block is the first number, and whatever's in this block in decimal is the second number for AF. So this equals AF 4 3, which we see right there. All right. Let's go backwards and let's do AF 2 2. See if we can do this. So 2 would be 1, 2, 4 would be 2 and 2, because that'd be 1, 2 and 0. So that'd be 16 and 4. So that would be 20. DSCP 20 equals AF 2 2. And there we have DSCP 20 is AF 2 2. And the number that we have there, 010100, is what we've got here. So that's the translation. So you will see in the binary element there is what you'll actually see in the DSCP field. And then you can either call it, like this, you could call it, it's 20, or it's a class 2 precedence 2. Most of them are going to be 11, 21, 31, 41. They're all going to be a class. The precedence is always going to be 1, so it's just going to be 2 different classes, except for voice or anything else that's super high priority, which will be 46. What would 46 be? 46 would be 32 and 14. Right? 30, 40, yeah, and 14. So it'd be 8 and 12 and 2. So that would be 1, 2, 4. Class 5, precedence 3. So that should be a 53, but it's usually classified as EF 53 instead of AF 53 because it's expedited forwarding instead of normal forwarding. Okay. So in the textbook, let's go back to see if I get, that was the dot cam. There we go. If we get back to the textbook and I can get out of the enlarged view here. Can I get out of enlarged view? Nope, don't want to do that. Gonna page down, a page up, page down. Let's go back to, there we go. Back to the book. There we go. Okay, so it actually shows you some like mathematical formula to do it. It's much easier, I think, to do it in binary. So blah, 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 blah. There's talking about voice over IP. All right, so here's explicit congestion notification, and it's the last 2 bits in that. So the first 6 were what we just talked about. This last one is it's either no congestion or congestion is being experienced, or can't do explicit congestion or disregard. So both zeros, and typically we'll have all zeros. In almost everything we're going to look at, it's going to be all zeros because we don't have enterprise equipment that's actually tagging these packets. Just home equipment's not going to have congestion, and you're not going to have equipment that's expensive enough to be able to determine congestion and do what we just watched in that last video did. So We can't do ECN as both zeros. Just disregard it as a 1. A 2 or a 1-0 would be we're good with it, but there's no congestion at the moment. And a 3 or a 1-1 would be we're having congestion at the moment. Again, it's not something that you're probably going to see, but I think you should know how to do that. Wireshark decodes only the 0 point as capable and incorrectly does both ECT1 and C as set. So basically that says in Wireshark, just ignore that. Okay, so that gets you, between those two videos, that should get you an overview of the table on page 106 and what DSCP does and why. It would be in enterprise networks where you have expensive equipment and you have more data on the network than you have bandwidth available, and we have to start making decisions on what are we going to keep and what are we going to drop. So we start classifying things, and it makes sure that real-time things, UDP stuff like voice over IP and streaming stuff, can get through on time, and the TCP stuff that potentially could be delayed and it's not super time sensitive could be tagged and could be dropped. If it is dropped, then it's going to resend later. And, there might be a second or two delay on that, but it's not going to, we're going to take that hit instead of disrupting our voice over IP streams or anything else that's really, really time sensitive. All right. Talk to you next time.